Welcome to a series that I'm going to call the AP Physics 1 Question of the Day. Volume 1 because the test is changing next year to add fluid dynamics. So that'll be volume 1.5 when that ends up happening. So with this series, we're just going to go through a concept from AP Physics 1, kind of go through a question based on that, going through how to justify things. That's a big thing on the exam nowadays. So let's get into our first part here. All right, so what we have here are some facts of physics. These facts of physics were not written by myself. They were written by another teacher. His whole fact sheet is linked in the description down below as well. What essentially he did was he went into or that group of teachers did working with him. They went into a textbook or multiple textbooks and took out ideas from this textbook and were able to kind of break them down in a much simpler way than the textbook was presenting them. What typically happens with physics textbooks is these people or professors have been doing this for 30 years. They write the textbook to how they understand physics, and it's going to be at a much higher level than an introductory student is going to have an understanding of it. So the way these facts are essentially written out is to make everything simpler and they kind of take some of the physics speak out of it, essentially, that makes it too difficult to understand. A lot of the stuff is I wouldn't say dumbed down, but just made a lot simpler, so anybody could pick it up and be able to understand what is happening or start to kind of formulate the concepts within their mind. Conceptual physics is a big idea in AP Physics 1. It is not just a math course. If you're doing a lot of math, there's something wrong with that. Essentially, you want to learn the concepts. The math is not the biggest deal here. So I'm not going to explain all these facts. What I would say to do is take a screenshot of this if you want to refer back to it. I'm also going to have the facts in the description down below for the entire unit of kinematics. And I will link also the full fact sheet from the teacher that I adapted this from. The questions are all original questions though, so they're just based on these ideas in AP Physics 1. So let's get into our example. So again, into our example here, we have the graph below represents a toy car as part of a demonstration the first week of school. A motion detector is set up pointing to the right. We have a graph down below it. It is a position versus time graph. And how far does your car move in the 5 seconds shown? And we have to justify our answer here for part A. All right, so whenever you justify something, at least in my class, what I do is evidence, reasoning, claim. This is just a play on claim, evidence, reasoning. The reason why we start off with the evidence first, which is a fact of physics, is when you have a fact first or the evidence first in front of you, you're not just going to make a wild claim and then attempt to kind of justify that claim based on things that just do not exist. So since you have the evidence first, you have hard evidence or a fact of physics, it's a lot easier to be able to go forward with your answer than just making a claim on the graph, a claim that could be wildly incorrect, and then you're just going to go through a lot of hoopla in order to say that this claim is going to be correct because you make the claim first. So starting off with the evidence kind of keeps you from making that mistake of just doing things because you made a claim and you want to make sure that that claim is absolutely correct because you were the one who made it. All right, so for this graph here, you're going to look at your facts of physics. So either you screenshotted the slide beforehand or you got them from the description down below. So you're going to go to position time graphs. So in position time graphs, you have a few facts here. So to determine how fast an object is moving, look at the steepness of the position time graph. That's your first fact there. So let's look through all of these facts and see if there's one that can help us with the first one here, trying to see how far does your car move in the 5 seconds shown. So look at the bottom of my position time graphs. I can see here to determine how far from the detector an object is located, look at the vertical axis of the position time graph. All right, so my position time graph, the vertical axis starts off at 2. Below it, there is a smaller dash, so that is going to be 1. In between the even numbers, there's a dash, so those are all the odd numbers essentially, without them being on the graph. So if I look at my graph here, I'm going to line this up with the top of my graph. So on the vertical axis, this is the top of it, and then we just line this up with the top of my graph. All right, so looking at this on the vertical axis, my evidence here to determine how far from the detector an object is located, look at the vertical axis or the y-axis of the position time graph. So my vertical axis lines up with my graph here, which is the green slanted line right there, and that is going to be lined up with 15 meters. So my full justification would be my fact first. To determine how far from the detector an object is located, look at the vertical axis of the position time graph. And then you can say, since my position time graph, or the top of my position time graph, lines up with 15 meters at 5 seconds, then I was 15 meters away from the detector at time 5 seconds. So I'm going to have this typed out now so you can see it a little more clearly. So begin here again, this is my evidence to determine how far from the detector an object is located. Look at the vertical axis of the position time graph. That's my evidence. So now my reason, since the graph is at 15 meters on the vertical axis after 5 seconds, that's the reason. We can then conclude, which is my claim, that the car is 15 meters away from the motion detector. So that is going to be my full answer here. So let's move into part B of this question. All right, so part B, which way does the car move during the 5 seconds? And we're going to answer with the direction of left or right. So again, we're going to justify this. First off, I'm just going to go through my thought process for something like this. So we have up at the top that the motion detector is set up pointing to the right. So whenever I do this, I just create an arrow of which way the detector is pointing. Since it says it's pointing to the right, I'm going to create an arrow here and just put detector here to the right. So just write out detector so I know that's what this is. Then I'm going to look at my graph. So which way does it move during the 5 seconds? I'm going to use my fact here as evidence. So let's look at the graph. The graph is creating a front slash, a slope like a front slash. So I look at my fact sheet and I see that a position time slope like a front slash means the object is moving away from the detector. So that is going to be my evidence there. Evidence is going to be my fact, position time slope like a front slash means the object is moving away from the detector. So since this graph is shaped like a front slash, that means it's moving away from the detector, and the detector is pointed to the right. So in order to move away from the detector, I have to then also move to the right. So then my car has to be like this. This arrow would then be the car. And you see here, if the detector is pointed to the right, to get away from the detector, I also have to go to the right side. So I have this written out here on, I'll have this typed out here in the bottom. All right, so position time slope like a front slash means the object is moving away from the detector. That is my evidence. That is my fact. Since the graph has a slope like a front slash, this means that the car is moving away from the detector. That is my reason. A little more reasoning here. We can conclude, or this is my claim, we can conclude that it moves to the right as the detector points right. So the car would have to move to the right to move away. So that is also shown by my arrows up there as well. So detector pointing to the right, car has to move to the right to get away. That should make sense. So let's move into our last part here. All right, so C. Is the car A, speeding up, B, slowing down, or just moving at a constant speed? So again, we are going to look at our graph here and the facts that go along with this. So our position time graph facts, the first one that I actually see up here, to determine how fast an object is moving, look at the steepness, i.e. the slope, of the position time graph. All right, so what's steepness? Steepness, something that is very steep, is going to be essentially straight up and down. Something that is not so steep is going to be essentially flat. So we look at steepness, you want to see if that steepness is changing, if it's becoming more steep, or if it's becoming less steep or flatter essentially. So in this situation, I look at the graph and it seems to be that we have a slope that is not changing. That means that my steepness of the graph is not changing. So if my steepness is not going to change and the steepness of the graph determines whether my speed, that means that I have a constant slope or a constant steepness, and I will then end up having a constant speed. So we can start off with our evidence first to determine how fast the object is moving. Look at the steepness of the position time graph. I can then say, since the steepness of the graph it does not change or the steepness is constant, my speed of the car is also going to be constant. So that's what I should have written out here or typed out here. So to determine how fast an object is moving, look at the steepness, i.e. the slope of the position time graph. Since the steepness of the graph remains constant throughout the motion, we can conclude that the car moves at a constant speed. All right, so that is our last part here. I hope this helps you understand position time graphs a little bit more, and see you guys all in class.